So for this chapter, we are doing multiples of pi over 6 and pi over 4. It's really important that you know that the angles that is related is actually 30 degrees, 45 degrees, and actually a 60 degree. So if we write this in radian, this is a pi over 6, this is a pi over 4, and this will be a pi over 3. So let's say we have an equilateral triangle. So an equilateral triangle looks like that. And let's say this is 60. It's definitely 60, right? Because it's the same on all sides. So this will be 60 and this side will be 60 as well. So if this is 2 centimeters in length, this will also be 2 centimeters. And this will also be 2 centimeters. So this is quite straightforward. So now if I decide to just cut the triangle into half and take out maybe this bit. So let me just transfer this to here, maybe. So hopefully it looks the same. So copying down this angle, which is 60. If I take out half of this, this will be 90 degrees and this will be 30 because this is halved. And if this is 2, this will be 2 as well. And if this is halved, initially this is 2, this will be 1. To get the height of this side, we need to use the Pythagoras Theorem. So from the Pythagoras Theorem, we know that height square plus 1 square equals to 2 square. Height square equals to 2 square take 1 square, which is 3. So we know that our height is a square root 3. So it's a square root 3 here for the height. So now, because this is about trigonometry, how is this related to sine, cos, and tangent? So remember, the first time we learned this, we have a magic word called the SOHCAHTOA. So where SO is sine or it equals to opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. So we are using the same method here, in here. So let me just copy out the magic word, SOHCAHTOA. And then we looked at sine, cos, and tangent for these angles over here and make it into like some sort of like a table. So we have a table here. So when we are talking about maybe the angle 30 degrees, so we need to be looking at 30 degrees, which is here. So 30 degrees sine 30 will be opposite over hypotenuse. So this will be the opposite over hypotenuse, which gives us 1 over 2. So this is 1 over 2. Cos will be adjacent over hypotenuse, which is square root 3 over 2. Tangent, back to this angle again, is opposite over adjacent, which is 1 over square root 3. So now that we are done with this side, perhaps we can look at 60 degrees first. So let's say 60 degrees is the orange one over here. So what is sine 60? Sine 60 is, sine is opposite over hypotenuse. So in this case, it's square root 3 over 2. And then we have cos 60 is AH, adjacent over hypotenuse. So that's 1 over 2. And then going back to 60 again, we need to do tangent, which is opposite over adjacent. So that's square root 3 over 1, which is just a square root 3. So now that we are done with this triangle here, what about the middle column over here? Maybe we can write or we can draw another triangle, which is an isosceles triangle. So isosceles triangle. So it means that these two have the same length here. So if this is 90 degrees, the two sides will be 90 divided by 4. So this is 45 and this is 45 as well. And then if we want to have this as a length. So for example, if this is 1 and this is 1, what about this length? So using the same Pythagoras theorem that we have done before, we need to side square at this side square equals to hypotenuse square. So 1 square at 1 square is 2 equals to h square. So my h is a sort of square root 2. So this is square root 2. So now that we have this, we can actually look at 45, the angle 45 degrees, which is this one. You can take the other one, that's fine, because you will get the same answer. So for sine 45, it's opposite over hypotenuse. So that's opposite over hypotenuse, which is 1 over square root 2. For cos is AH, so that's adjacent over hypotenuse. So that's 1 over square root 2 as well. For tangent 45 degrees, it's opposite over adjacent. So that's just 1. So this is a very important, let me just highlight the whole table. This table is really, really important. It should be in your reference sheet for your test, because all you have to do is refer back to this one and you'll be able to solve most of the questions there. So I'm not hinting what's coming out for the test, but this is an important table. So now that we know this, how does this relate to the unit circle? So as we learned just now, the unit circle is a Cartesian plane with a circle, and every single unit here is 1, -1, that's 1, that's -1 over here. So when let's say we have let's say we focus on the second column, which is pi over 4. So what does this mean? It means that if this is 90, half of 90 is sort of like a pi over 4. So, and we have also learned before that in a unit circle, the coordinate could be cos theta and sine theta instead of x and y. So we have to remember this as well. So if this is pi over 4, so we know that now that the angle is pi over 4. So what is the value of my coordinate? So the first one needs to be the cos of pi over 4. The cos of pi over 4 in this case is 1 over square root 2. So after I've done this, the second one is my y coordinate, which is my sine pi over 4. So that would be my sine, whoopsie. So the first one is cos, it should be this one, but luckily it's the same. And the second one is 1 over square root 2. So this is the coordinate of my point here. So let's say I have another 45 degrees over here. So drawing this, we have pi over 4. And then let's say we have another one here, pi over 4. And we have another one here. So they are all pi over 4. And okay, you have to remember why I'm using all the angles here, because this is what we learned before. The angles that we use need to be the one that's closer to the x-axis. So of course, this will be also a coordinate. So this will be also cos and sine. And because this is the same angle as this one, the cos and sine is the same. So that's 1 over square root 2. That's 1 over square root 2. This is also 45. So the coordinate for this point is also 1 over square root 2, 1 over square root 2. And the coordinate for this point is also 1 over square root 2 and 1 over square root 2. But wait a minute. All the points are at different locations, right? It couldn't have the same values. So that's when the all CVU teachers cute, this concept comes in. Okay, so what does it mean? So all CVU teachers cute. I don't really think so, but it's okay. So as long as we remember the concept. So in this case, because all is positive, so we have both values that's positive over here. And because in this case, sine is positive. So only sine is positive. That means that the cos is negative. So the cos is negative, but sine is positive. We'll just leave this alone. So now that we are looking at the third quadrant, the tangent is positive. So what about the cos and the sine? Of course, they will be negative. Is this okay? So if we look at the fourth quadrant, so this is when your cos is positive. So the first one is positive. And the second one, which is the sine, will be negative. Does that make sense? So hopefully you understand this because it's the same concept for the other two columns. So now let's get down to solving questions that is related to this. So for example, we have one question that's like find the exact values of sine alpha, cos alpha, and tangent alpha. Okay, for alpha equal to 3 pi over 4. So in this question, we need to find the value of sine alpha, cos alpha, and tangent alpha. So don't get confused. It's not as complicated as you think. So let's say I draw the Cartesian plane. Okay, so going back to the unit circle, we have the circle, and we have this is 3 pi over 4, so that's really near to here, so it could be somewhere here. It's not super accurate, but that's fine. So this is 3 pi over 4. So we know that if this is 3 pi over 4, the complementary angle is pi over 4 because we take pi, take away this. So if we look at this, we know that pi over 4 has to do with the table of value here, which is pi over 4. So we need to be focusing on this table of values. So in order to solve for sine alpha, we need to know that sine alpha is sine pi over 4. Sine pi over 4 is 1 over square root 2. So that's 1 over square root 2. And from here, it is very important for us to decide what is the sign for this. Is it a positive or is it a negative? So going back to all CV teachers cute. So all CV teachers cute. We are looking at the second quadrant here, and therefore sine is positive. So in this case, sine is positive, and we'll just leave the value alone. So the second one, we have to solve for cos alpha. So cos alpha is cos pi over 4. Cos pi over 4 is also 1 over square root 2. 1 over square root 2. And because we are still at the second quadrant over here, and at the second quadrant, sine is positive, so my cos is negative. So that's the value of cos. And tangent alpha is tangent pi over 4 is 1. And from here, we know that because only sine is positive, cos and tangent is negative. And because the question says find the exact value, we will just leave the answers like that. Please do not divide it and find some decimal places that you round it off, because once you round it off, that would not be exact. So now that we know how to do this, let's do another question that is sort of similar. So drawing a line, we have to find the, again, exact values of sine 4 pi over 3 and cos 4 pi over 3 and tangent 4 pi over 3. So now the angle is given. Let's draw the unit circle again. Let's draw the unit circle and unit circle. So 4 pi over 3 is more than pi over 3, and therefore that's pi and that's 0. So 4 pi over 3 is somewhere here, maybe. So that's 4 pi over 3. And we know that the little angle, the acute angle here, it's a pi over 3. the first thing we need to solve is sine 4 pi over 3. So sine 4 pi over 3, let's just copy 4 pi over 3 is equivalent to, we can't get 4 pi over 3 here. So we need to relate it back to the acute angle, which is pi over 3. Pi over 3 is this one. So a sine pi over 3 is square root 3 over 2. So square root 3 over 2. Is this the answer? Nope. You need to, again, all CVU teachers cute, you need to always remember to decide what sign it is. So for this one, this is the third quadrant. So this is a quadrant where tangent is positive. So definitely sine is a negative, and we are doing cos as well. So we know that before even finding out the value, cos is definitely a negative. So what is the value of cos? We have to cos pi over 3. Cos pi over 3 is a half. So we need to put half here. And tangent 4 pi over 3. What do we get from here? Tangent 4 pi over 3 will be tangent pi over 3, which is a square root 3. So this is the only one that is positive because it's at the third quadrant. And at the third quadrant, only tangent is positive. So if we look at another question, this is another question. Without using a calculator, we need to show that 8 sine pi over 3 cos 5 pi over 6 is equivalent to negative 6. So in this case, the answer is already given. We need to actually find the working and explain why this could possibly become a negative 6. So the first thing we need to do is to find out what is sine pi over 3. So sine pi over 3 using the table that we used just now. A sine pi over 3 is a square root 3 over 2. So sine pi over 3 is a square root 3 over 2. So now that we have gotten this one, we have kind of gotten this part here, we need to kind of figure out what this part means. So cos 5 pi over 6, cos 5 pi over 6, what is the value of this? We need to draw the unit circle. So this is 0 and this is pi. A 5 pi over 6 could be sitting somewhere here on this line. So that's 5 pi over 6. And the corresponding angle, the small one here, it's a pi over 6. So we can take the corresponding acute angle. So this is pi over 6. A cos 5 pi over 6 will be cos pi over 6. Square root 3 over 2. Square root 3 over 2 again. But because we have all CVU teachers cute, we need to decide on the signs for this too. So all CVU teachers cute. This is the second quadrant. The angle is at the second quadrant, so we only look at this bit here. So sine is positive. This is fine. The cos needs to be negative. So this is the value when I find them separately. So now let's put this value back into here and this value back into here and see whether we can get negative 6. If we can get that, that's done. So 8. So instead of sine pi over 3, we have square root 3 over 2. And instead of cos 5 pi over 6, we put negative square root 3 over 2. Okay, the defining moment. Let's take the calculator, turn it on. So we have 3 times square root pi. So where's square root? Square root 3 over, okay, that's wrong. We need to just this one, square root 2, and then times negative square root 3, square root 3. Remember to press the right button and then over 2, press the equal sign. Oopsie, that's an 8. Let's do it again. That's an 8. Okay. Okay, so I got -6, which is the same as this one. So this is done. I have shown that this equation is equivalent to -6. Okay, for the next question is find all angles when theta is between, let me copy this. Find all angles when theta is between 0 to 2 pi with cos half. Okay, with cos of half. So it means cos equals to half. So how do we do that? We need to remember that cos is a positive half here. So which quadrant does it lie on? So all CV teachers cute. When cos is positive, it's this one and this one that we want. So going back to the unit circle, we want this angle and this angle, and we need to get cos value of half. How do we do that? We can use this table again. So when cos is half, which angle are we talking about? A pi over 3. Why am I taking pi over 3 instead of 60? Because let's look at the question. They need it in radian. Okay, so I'm taking pi over 3. So this is, of course, like what we do all the time. We need to get the angle that's always closer to the x-axis. So this is pi over 3. So this is also a pi over 3. So how do we get the angle, this and this, if we turn it a full turn? We always need to calculate or start from this line. So from this line, we need to spin anti-clockwise from here to here, touching this line. We get theta is pi over 3. Do not write the cos, because when you write the cos theta is actually a half. We just want the theta. And then again, the other angle will be always starting from here. We always turn anti-clockwise. So turn up to here. That's a pretty big angle and we don't know what's the value. But we know that this is the unwanted bit here. So it's kind of like one circle, which is 2 pi. Take away unwanted bit. So what do we get? We get, just give me a moment. So 2 pi, take pi over 3. We get 5 pi over 3. Or if you want to write 5 over 3 pi, that's fine. They are the same. And the other angle is pi over 3. So this will be all the angles for 0 to 2 pi with a cos of 1 over 2.